So we're going to look at a few more graphing examples and try and get some ideas of what some of these polar equations look like. So we've seen, a few circle and then a line are our constant equations, but y equal x squared, we did see that one when we did the conversion. It was r equals secant tangent. What about r equals 3 sine theta? Let's look at that one. And, since we don't have a good idea of, in general, what polar graphs look like, let's just start with the basics on this one, pick theta values, and then plug in to get the r values. So I picked theta was 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, and pi. And then we're going to plug our theta in here to get our r value. So theta 0, 3 times sine of 0 is 3 times 0, which is 0. Pi over 6 for theta, so 3 times sine pi over 6. Sine pi over 6 is 1/2, so this is 1.5. And then you keep doing that. So sine pi over 4 is root 2 over 2. We get about 2.1 for our radius there, then 2.43, 2.4, back to radius 0 at pi. So let's take a look here. So our biggest radius here is at 2.5. So why don't we scale this off? Oh, no, I'm sorry. Biggest radius is 3. So why don't we scale this off as 1, 2, and 3. So first we've got 0, 0, which is right here at the origin. And then we've got angles pi over 6, radius 1.5. So we go out 1.5. Remember, pi over 6 is here. Pi over 4 here. Pi over 3 here. And pi over 2, 90 degrees right there. 2 pi over 3 would be right here. And then across from pi over 4, 3 pi over 4 here. And then across from pi over 6, 5 pi over 6 here. So the radius is 1.5. You go up to an angle of pi over 6. So we go out 1.5 up to pi over 6 right there. Radius 2.1, angles pi over 4. So out 2.1 up to pi over 4, about right here. Radius 2.4 at pi over 3, so go out 2.4 up to pi over 3, about right there. Radius 3 at pi over 2, so that will be, we go out to 3 up to pi over 2 right there. And then 2.4 at 2 pi over 3, so go out to 2.4 over to 2 pi over 3, so right here. And then notice that that point is right across from this one, and that's because the sine of pi over 3 is the same as the sine of pi minus pi over 3. So if you reflect across the y-axis, you've got y-axis symmetry with this graph. So this point here is going to correspond to a point over here, and then this one here will correspond over here. Okay, and then we're back down. So it's going around like this, and if we connect up those dots, we get a circle. So this is actually a circle. So my points are not exactly right on. Looks like these two guys are off a little bit here, but we get a circle. And we're oriented counterclockwise is our theta increasing. We don't need to put an arrow on that curve. But this is a circle along the y-axis. So circle along the y-axis. And notice that the 3 here is the diameter. Okay, so that 3 right there, that's the diameter of the circle. And if it was 3 cosine theta, it turns out that, that is 3 cosine theta would be a circle along the y-axis, I'm sorry, x-axis of diameter 3, so that would look like this. So in the red there, this one is r equals 3 cosine theta. So it's along the x-axis instead of along the y-axis. So that gives you some ideas about how circles are graphed. And if it was a negative 3 sine theta, then it'd be along the negative y-axis. Negative 3 cosine would be along the negative x-axis. So in example number 9 here, we're going to use something called range analysis. So this is the Cartesian graph of r versus theta. So theta is down here, and r is up here. So that's r is 1 plus cosine theta, or 1 plus cosine t. And then over here, I've listed some ranges of theta. 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to, this should be 2 pi. And then we want to list, well, what is happening to the radius in those ranges? And the radius is the vertical height on this graph. So we graphed one cycle of this. This is 2 pi, and then this is at pi, and then pi over 2 right here, and then 3 pi over 2 halfway between right here. So as theta goes from 0 to pi here, from 0 to pi over 2, your radius goes from here to here. So it goes from radius, this is 2 up here, that is 2, and that is 1, and that is 0. So it goes from radius 2 to radius 1. Okay, so radius goes from 2 to 1. And then as theta goes from pi over 2 to pi, so that's from here down to here, your radius, which is your height, goes from 1 down to height 0. So this goes from 1 to 0. As theta goes from pi to 3 pi over 2, so that's right here, your radius goes from 0 back to 1. And as you go from 3 pi over 2 to 2 pi, so that's right here, your radius goes from 1 back up to 2. Just reading off the y-coordinate there. So that kind of helps you get an idea of what the graph's going to look like here. So let's put our x and y axis on the grid here. And then remember pi over 2 up here. And then this is, let's see here, it's pi over 2, pi, 3 pi over 2, and 0, which is also 2 pi. And then let's see here, our maximum radius is 2, so let's scale this off as 1 and 2. So first we start out when theta is 0, radius is 2. So radius 2, angle 0. So that is actually going to be out here. So you go out 2 radially. And then as theta goes from 0 up to pi over 2, so as you go this way, you don't stay out at radius 2, you go down to radius 1. So that point, instead of spiraling, or instead of just rotating counterclockwise like that, what it does is it spirals down here to radius 1 at pi over 2. So it goes something like this. And then as your angle goes from pi over 2 to pi, so let me draw our angle there. So this was from theta equals 0 to pi over 2, and our radius went from 2 down to 1. And now as we go from pi over 2 to pi, our radius is going to go from 1 down to 0 as this rotates around. So that's going to give something like this. Whoops, let me go back to black here. So you're going to get down to radius 0, you're at the origin there. Then as your angle goes from pi to 3 pi over 2, your radius goes from 0 back out to 1. So at pi over 2, we're back out here at radius 1. So then your radial segment increases in length. And then as you go from 3 pi over 2 to 2 pi, your radius goes from 1 back out to 2. So from 1 back out to radius 2. So it's just kind of a mirror image of what's above the axis. So again, what you're looking at is this. So we start here at angle 0. We're at radius 2. As you rotate around, as the angle increases to pi over 2, the radius decreases to 1. As you rotate around again, from pi over 2 to pi, radius decreases to 0. Rotate again to 3 pi over 2, radius increases to 1. Keep rotating to 2 pi, radius increases to 2. So that's called range analysis. So that can help you graph the polar graph from the Cartesian graph of the equation. So look at WebAssign section 10.3, problems 6 through 8. Use either plotting points like we did up here or analyzing the range, what happens as theta and r change together. By the way, this figure here is called a cardioid because it kind of looks like a heart. It is a cosine cardioid, so it's along the x-axis. If it was 1 plus sine theta, it would actually be a cardioid along the positive y-axis, so that would look like this. So this one would be r equals 1 plus sine theta. And then if you had 1 minus cosine theta, it would be along the negative x-axis. 1 minus sine theta would be along the negative y-axis. So those are called cardioids.